So we have one more concept to add to our toolbox here before we can really properly talk about inverse functions. And the issue that we're going to be concerned with is that not all functions have inverses, right? To be invertible, a function has to be what's called one-to-one. And that's the concept that I've got here, right? A function is one-to-one if and only if every value from the range is mapped to exactly one value in the domain. And I want you to flash back to our definition of a function. Remember, something is a function only if every x value gets mapped to exactly one y value. So look at this function over here on the left-hand side. This is y equals x squared. Right? -2 goes to 4. And let's see, -1 squared is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So this function, this is a function, right? Every x value has one arrow coming off of it, and it's going to one number on the y column. All right, this function is not one-to-one because the reverse is not true. 4, for example, gets paired with both -2 and +2, right? So there is a number in the range that is not mapped to exactly one value in the domain. In fact, there's more than one, right? 1, for example, also gets mapped to two domain values. All right, so over here on the other side, I have an example of something that is a one-to-one function, right? This is y equals x cubed. -3 cubed is -27. -2 cubed, 0 cubed is still 0. 2 cubed is 8. And 3 cubed is 27. It is a function because every x value gets paired with one y value. And it is, in addition to that, it is also a one-to-one function because every y value gets matched with exactly one x value. All right, so how can we determine if a function is one-to-one by looking at its graph? Well, you remember when we talked about functions, we had this thing was the vertical line test, where we asked this question: can you draw a vertical line that crosses the graph more than once? And if the answer to that was yes, then it wasn't a function. Well, what we need here is something that does really fundamentally the same thing, but looking at the y values instead of the x values. So when we're talking about one-to-one functions, we have what's called the horizontal line test, right? And it asks the same question: is there a horizontal line that crosses the graph at more than one point? For this parabola, there is, right? So this graph, while it does represent a function, is not one-to-one. And over here on the other side, if I start drawing horizontal lines here, there is no horizontal line that crosses that graph more than once. So this is y equals the square root of x. This is a one-to-one function. All right, so with this new concept in hand, we're squared away, right? We're ready to really take the next big step and talk about what it means for something to be the inverse of a function.